All right, everybody. Welcome to today's Training Tuesday. I am your host and narrator today. I am Charles Hoke. I am the National Training Manager here at Dayton Superior. And as always, when we talk about Training Tuesday, this presentation is intended for training purposes only. And if you need assistance, please refer back to Training Tuesday or DaytonSuperior.com for assistance. So, who is Dayton Superior? Dayton Superior is the leading provider of concrete forming accessories and forming within the concrete industry. You are looking at a company that actually has approximately 35 to 39 engineers handling all different forms of concrete forming, from snap ties to modular forms to shoring to heavy duty systems. Uh, we also are leading developer in the concrete chemical industry and in the concrete accessory end of the business. So, and as always, we have our Training Tuesday classes here, and they are going to be recorded and posted in and on YouTube, just as we normally do. So typically, it's going to be about a couple of days. It'll be posted up to you on the YouTube channel. So today's class is going to be in regards to mechanical splicing, form savers, and bar locks. Now, form savers is kind of a universal term that was actually given to a product here back in the early 80s. Uh, this system here, when we're talking form savers, it was a mechanical splice system developed so that what it would do was eliminate the need for holes to be punched in the concrete forms. We're looking at, in today's market share, think about it. Six holes in a piece of HDO plywood typically would warrant replacing that plywood. So you're talking at right around about $100 to replace that sheet of plywood. So you're talking a fair amount of money here. Most companies typically do not penalize you for putting nail holes in the forms. So therefore, form savers become very advantageous cost wise. And there are some other hidden benefits with it, as will allude to here as we move farther along in this presentation. And then obviously we have our bar lock coupler system, which is a mechanical threaded system, mechanical splicing system, no threading required. It basically works with just standard cut rebar with a what we would call a shear bolt type connection. So when we talk about splicing, we have a couple of different options for it here. Lap splicing was probably one of the oldest systems within the marketplace here. And we are looking at where you basically lap two pieces of rebar, depending on the size of the rebar and the criteria that's required within the specification, will determine the overall lap length. Same thing with the weld length. Typically, two pieces of rebar put together and a weld will be assessed to it. Um, only problem is most of the states use especially on the East Coast, use an A615 grade rebar. A615 grade rebar is typically not weldable or bendable. So if you're on the West Coast, you have A706, which is bendable and weldable rebar. And we're seeing that to actually migrate across the country now. So more and more fabricators and so forth are supplying A706 type rebar. And then obviously our mechanical coupler system. Uh, the mechanical coupler system can be a variety of things. You can have a threaded with a parallel or tapered thread. Uh, both of those systems here are available from Dayton Superior as a parallel or tapered thread. You can have a shear bolt system. There's also a sludge system out there and a grout filled system with the grout sleeve type system. So in splicing, we typically follow the requirements of CRSI, Concrete Reinforcing Steel Institute. And just recently, within the last couple of years, CRSI has made some changes to the A615, and actually there's some more changes coming out here shortly, with some additional changes. But in 2020, the revision to A615 stated that the tensile strength requirements for grade A615, grade 60 and 80 have been reduced to 80,000 PSI and 100,000 PSI respectively. These same requirements as A706, which is a more of a ductile type rebar. So with these changes, 706 material now meets all chemical and mechanical requirements for the respective sizes in grade A615. So in other words, A615 and A706 are equivalent bars materials. Historically, bars marked with a W are certified to meet A706, S to meet A615. So now bars with a W can be substituted and used selectively for any of the requirements of A615 or A706. So the two bars are now interchangeable. The A706 and 615 specification may permit bar with only a W mark and certified to meet A706, but this change has not been adopted as publishing of this bulletin. So basically what it is, they're saying if you have an A706, you can substitute it for A615, but you can't typically substitute A615 in with an A706. So the producers may this is supposed to be coming through here. We'll probably see this in the next agenda coming up here. But what it basically results in is physical strength when we're talking splicing. We're talking physical strength for the rebar splice itself going through. So typically, here's what we have here with a type 1, type 2. And now what has happened is those numbers have changed to 80,000 pounds for a type specified strength of the rebar. A type 2 is now going to require 80,000 PSF for a type 1 and, excuse me, for a type 2 and 100,000 for a grade 80 rebar. So when we're talking about physical yield with the bar, Dayton Superior, we produce a multitude of different types of slices. All of our slices are both designed for compression and tension. So when we're talking about tension, it's basically bars being pulled apart from when they're made that physical connection. And compression, obviously, is when they're being pushed together. These are all of these systems here that we're going to talk about today are very good in both tension and compression. So yield strength is what we're talking about is a huge factor that what we deal with here. That's the stress to which the reinforcing bar under an applied load will stretch. And once the load is removed, to return back to the original length. In other words, acting like a rubber band. So it will elongate a little bit and then slide back to its original position. The physical yield strength is designated by the symbol F sub Y. Once the rebar has reached a yield point and has been elongated or stretched past the point, it will never return back to its original strength. So those are typically once you reach a yield point, the bar will not come all the way back. It's basically going to the point of prior to just getting to that failure mode. Form savers that we are using, bars protruding from the wall, dollar bars protruding. Where are you going to use them? Well, how many times have you seen rebar sticking out of a concrete wall or basically coming out of the going through this form to actually have a wall poured against it? This and even you'll see it on floor slabs where it actually becomes a trip hazard. So you can see on the far right-hand side photo here, photos of a floor slab or a wall slab with what we would call a form saver in place. And you can see how much cleaner and easier than something, say, on the slab where it's if you have rebar coming up through, you have to worry about tripping hazards, constantly having rebar in the way of trying to walk around, etc., pass equipment through. It makes life a whole lot easier on a job site. So we have our taper lock product. So here's we're going to start talking a little bit about some of the taper lock, some of the products that we have available. Our product portfolio, we have what we classify as our 300 series. The taper lock, this is where a piece of equipment will get installed into a fabrication shop. The fabrication shop will then fabricate the rebar for what the project is going to be required. And they have a multitude of different types of couplers that they can put in place. You're going to look at standard couplers uh, going in place to make a form saver relatively quick and easy. And what that's going to entail is threading the end of the rebar with our Type 2G machine. Uh, Typically, it can be done with plain galvanized epoxy, stainless steel, and Chromex rebar, anything from grade 60 to 100. And you're typically looking at speeds here, number 4 bar. Typically, you're going to do about 100 bars an hour can be done. Uh, 18 bar, you're still talking about 30 bars an hour. So, and the nice thing about this by having it in the fab shop is the fab shop can control the overall length, so you can reduce the amount of lap bar that you will have to make any of these connections. The DC 370 threaded bar is basically just a standard uh, threaded bar. Typically, you'd have for a normal form saver, you'd have 2 of these and a coupler that went with it. You can get this in with a hook end or a bent to whatever criteria you need. You can also get it with a forged head on the end so that you can have an end anchor system. And you can also have it with a bolt head put on the other end also for a smaller condition that is going to be required for anchorage. Now, the couplers that are available are 310 standard. Typically goes 2 bars, same size, anywhere from 4 to 18. No flange on this, so basically is going to be what we would call a through coupler. So it's connecting 2 bars in line going forward. You have our transition coupler, which is an inline coupler, changes bar sizes from one size to the other. Great for columns and so forth, where you have to make those connections from reductions of rebar as you move upward. We have our form saver, our D340. It is the standard 310 coupler with a washer flange put on top of it, on front one side of it. And this enables you to connect it to the concrete formwork. It's a very common form saver. Most people really like this one because you don't have to worry about getting a shorter length and then having a lap length right there. If it's done in the fabrication shop, you'll see longer lengths being applied, so it reduces the amount of rebar in lap. You can also get threaded end anchors for this system. And you also have positional and weldable couplers that can accompany any job site circumstances that may arise. So our 310, 340 couplers, as we talked about, straight inline couplers, they run down through. You've got for um, upright connections, floor slab connections, floor slab wall connections. You can also see our 340 flange coupler here going in place. And those are all typical standard form saver type applications. We also have our parallel system here that typically comes in uh, sizes 4 through 14. You can get this standard lengths required. Does meet a type 2 requirements with this system. The DBDI system, like I said, does come 4 through 11 on standard sizes. The nice thing about a parallel system, you do not have to have any tools to torque it or tighten it in place. Uh, this system, similar to our taper thread system, our taper lock system, uh, you can hand tighten it. This system here in particular does have the ability to actually be unscrewed half a turn to allow for position of the bar and still maintain strength capacities. Um, Basically, it's fully customizable for the project. It's a perfect for a form saver application. This system here has been around. The Have the structural flange on the female component here. Is very rigid, makes for a great connection to your forms. Or if you're doing a slurry wall type application, is a very good application piece to be put in place, can be dropped in the slurry wall. It's very rigid, so you don't have to worry about it getting dinged or ripped off or any of that where the flange would be on there. That flange is fairly stout in as far as strength and capacity. Installation of this product is typical. You would have your form saver comes in, you place where you're going to have it. You want rebar protruding through your concrete form, let's say in a bulkhead or in a floor slab type situation where you have phased construction. You attach this to your formwork with a couple of nails, uh, pour your concrete on one side, come back through, remove your formwork, and then thread another bar into that female coupler that was in place inside the poured concrete. Now there is a metal tab on the inside of the female component that will have to be popped out with a screwdriver. It's there to keep concrete out of it. So we don't have concrete or even epoxy coating when we have to do epoxy bars. So we can do hook systems with this, whether it be bent or a 180-degree hook. We have a chart that is available in an order form that can be sent to you from customer service. Makes ordering it and getting quotes very simple and easy. Just the one thing I will make mention is please pay close attention to the measurements. On the male components, it typically goes from the end of the thread on the bar and down the bar, as you can see here in our diagram here. On the female components, it goes from the end of the beginning of the coupler all the way to the end of the rebar. As I talked about, we can do our short-headed anchor system here. Uh, this system is really usable for when you're doing shelf angle brackets, etc. It is a ductile embed anchor that actually achieves excellent strength, can be used to actually anchor pretty much anything and anything that you've got in place here. Thread diameter is a standard NC thread capability. You can get these in typically, I think, from 5 inches all the way up to whatever length you're looking at, with a headed end on it. It's not a end anchor per se. It is a headed anchor, basically just a bolt head end of it. Um, so you're not looking at a full end anchor type situation. We can also, for projects here, such as bridge projects here, that, where we typically have a circular face on the washer face, we can clip the ends of it so that we make sure that we get concrete coverage over the top of that flange. We can clip the bottom side to make sure that we don't get any for concrete coverage on the bottom side. Head engineers have had issues with this system here in the past, so both of these can be done as needed. The system that we're talking about is a hot forge system. The DBDI system is a what we classify a hot forge system. You've got hot forge. I mean, you're heating it up to 2400 degrees, then shaping the rebar to whatever, the uh, either the bell housing or the end anchor is being accompanied by whatever shape you want here, and then it's being pressed into it. As you can see, it's been used for multiple different facets of wastewater treatment plants, high-rise construction. We've seen it in bridge and highway activity throughout the years. Here's a wastewater treatment plant. Great example of what a form saver can do for you in a form saver. You think about forming that concrete wall up with all those, if the rebar had to penetrate out, you spend a lot of time punching holes in your forms. Here, you can basically go through, form it up, have your rebar attached to the form saver attached to the form, strip your forms, then reattach the rebar for any penetrations or protrusions coming out of the wall face, and then form it up outside. Makes life a whole lot easier and also increases productivity on the job site, especially in your forming end of it. The bar lock coupler. Shear bolt coupler typically has a shear bolt connectivity. Uh, Premier functionality, it's a heat treated serrated rail within the center of it. The bolts will actually produce a pressure on the rebar to penetrate it, to push that into the serrated rail. That serrated rail then grips a hold of the rebar, giving you embed strength here. And you do get a type 2 strength requirement out of this product. Now, when this product was developed, back in the day, it was developed primarily as a repair splice. This repair splice basically was designed so you could chip away the concrete, spalled areas, slide a new rebar in place with the couplers on all of it, put it in place, slide the couplers back out to basically connect the old rebar to the new rebar, tighten down the rebar, form it up, and you're ready to go. Over the past few years, we've seen numerous movements where we're going into new construction, especially caissons, etc. You're seeing here we did hot dip galvanized in New Jersey. This is the Dallas Fort with the right on the left hand side. It's Dallas Fort Worth Airport. And here you're looking at some other projects that we've done here up in the Northeast with bar locks coming in where we've assembled cages as long as 140 feet and actually dropped them into for caissons for some of these piers and some of the riverways in the Northeast. So with these couplers, we've got a Type 1, a Type 2 for the D250L series. We have an XL series, which actually is a grade A80 compatible, type 2 for grade 80. We have transition couplers available, and we also have weldable couplers, and we have a weldable end anchor that's also available in this system here. Now, resources that are available. We've got product pages on at DaytonSuperior.com. If you're not familiar with the website, explore the website. You've got quite a few tidbits of information in there. You'll find product pages. You'll find technical data sheets regarding all of the splicing products that we talked about here and that we have within our portfolio. You'll also find handbooks available for your request here. You can actually download those from PDF onto your computer. You have DBDI order forms are available here. Any of the IAMPO forms are available on here. Any of the certifications are available online. And also, if you need to find out here, we do have technical specialists across the country in the Northeast, South, Southeast, Midwest, and West Coast. So if you need the assistance, basically go to just say, look in the top, you'll see where it says contact us. Click on that. That'll bring up our map page. Click on Dayton Superior, and then click on the region that you're in, and you'll see all the salespeople that are working out of that region. Everything from accessory to chemical to any of the specialists, whether it be for splicing, tilt up, etc. If you need additional training on here, please scan the QIR code here or actually drop us a note at training at Dayton Superior. Uh, this comes into Heidi and myself here. We offer lunch and learns. We do custom AIA, PDH classes for engineering offices. We can do in-person and virtual classes in regards to this. And we can also do any of the online trainings that you've got that you can basically call into at training two. If you go to www.daytonsuperior.com in the search bar, hit Training Tuesday, it'll bring you up to any of the training classes that we've already done in the past. And with that, I'd like to say thank you for your time. And if you have any questions, please put them into the chat functionality of the form and we will go from there. I'd like to thank everybody for your time. And it's like I said, any questions, please feel free to reach out to training at DaytonSuperior.com to ask for any information. Okay, I am not seeing any questions right now, so I am going to end the class right now and want you all to have a great day and a good rest of the week. Take care, everybody.